watching Damn Science.
As we have already solved question 1 and 2 of question paper 0620 chemistry of examination series October-November 2023. In this video, we're going to solve the remaining two questions, that is question 3 and question 4. So let's go ahead. So here is question 3, which is based on qualitative analysis, that is a student tests two substances, solid I and solution J. Now remember, solid I is a solid and J is a solution. Remember that. Let's go ahead. It says solid I is chromium 3 sulfate. Now the name of solid I is already given, that is the cation present is chromium 3 sulfate, so SO4 2 minus. So cation is chromium 3 and anion is sulfate, SO4 2 minus. So the test positive will be for chromium and sulfate ions. But let's see what are the questions, sub questions below this. It says the student dissolves solid I in water to form solution I, and the student divides that into 3 portions. Complete the expected observations. Now here it says, to the first portion of solution I, the student adds aqueous sodium hydroxide dropwise until it is in excess, and we are supposed to write the observations when sodium hydroxide is added to solution I. Now let's remember that aqueous sodium hydroxide and aqueous ammonia solution are added to test the cations, and we need to answer these questions looking at the last page of qualitative analysis table. So let's remember the test only, that we are adding sodium hydroxide. Let's go ahead with the sub question. Next also we'll see the answers for all these sub questions all together at the last page. So the first test was with the sodium hydroxide, and the second test is the student adds 1 centimeter cube of dilute nitric acid followed by few drops of silver nitrate. Now as we have already said that sodium hydroxide and ammonia are used for cation. So the next test is for anion. Anions is, what are we adding? Nitric acid and silver nitrate. Now let's understand that this is the test to check chloride, bromide or iodide ions. And the third portion, the solution I, student adds 1 centimeter cube of dilute nitric acid followed by few drops of barium nitrate. Barium nitrate, if you check the anion table, we'll understand that that's the test for sulfate ion. So obviously this test we are going to get the negative. Let's see what do we get with sodium hydroxide for chromium ion, and for barium nitrate is a sulfate test. Let's check. We should get that positive. So let's check the table where it says, here anion table. You can see that chloride, bromide and iodide are checked by silver nitrate, but as we don't have any of these anion, we will get the negative test. So we can say no observation, no reaction. In sulfate, we can say that the nitric acid and barium nitrate are added, which will give white precipitates. So this is the observation we'll get. And let's check for the cations. Sodium hydroxide aqueous we've added, and if we have chromate ion, that is not chromate ion, chromium ion, Cr3+, then we get green precipitates, which is soluble in excess when sodium hydroxide is added excess. The green precipitate dissolves. So this is what we are going to write in our observations here. So obviously when we added sodium hydroxide dropwise, we'll get green precipitates. I'll obviously advise you that don't write this in short. You need to write it in full words, but as I don't want to waste time here, I'm writing it in short. But the student should write fully green precipitates in the word with proper spellings. Okay, on observation on adding excess, we remember it dissolves. So green precipitates dissolves. We can write green precipitates dissolves. So it will obviously give a solution, but we don't need to mention it here. As we don't have any of this anion, we'll say no reaction or no observation. We can write it. And yes, for barium nitrate, we know the observation is white precipitates. So the observation written here for barium nitrate, which is the test for sulfate ion SO4 which is present in our compound I, so we get white precipitates. Fine, let's go ahead with the next part. Says test on solution J. Now the J is solution and it's divided into 5 portions, and the test and the observations are given. Use a glass rod to transfer 1 drop of the first portion of solution J onto a piece of universal indicator paper and it turns red. So obviously the substance is acidic because it turns red. Universal indicator paper shows the test for acid or base, and that too strong acid or strong base. So here we have got red, it is obviously some strong acid, so maybe a mineral acid. Let's go ahead. What do we get next? Test 2. It says to the second portion of solution J add a piece of magnesium ribbon. Test any gas produced. A piece of magnesium ribbon disappears and the effervescence is seen, and the gas produces a pop when tested with a lighted splint. Now we can see the test of the gas table, but here I'll tell you, if it's a strong acid, obviously it's going to produce effervescence with the any metal, because when acid reacts with any metal it produces hydrogen gas, and as any gas is produced, effervescence is seen, and if the gas is hydrogen it gives a pop sound with the lighted splint. But that also you can always check in the gas test table given on the last page. We'll check that. Let's go ahead with the test 3. It says about again dilute nitric acid followed by few drops of silver nitrate and we get white precipitates. Now as we have observed, already discussed in the earlier part of the same question, it says this is the test for chloride, bromide or iodide. So if we are getting positive result out of these 3, one is present, we'll check in the table, anion table, which halide ion is present. Fine. Test 4 to the fourth portion solution, add dilute nitric acid followed by a few drops of barium nitrate. Now no change. That says that sulfate SO4 is not present, because this is the test of sulfate, as we have already checked this in our earlier part of the same question. Test 5, it says do a flame test on the fifth portion and this lilac colored flame is seen. Lilac colored flame is seen. So suggest the pH of solution J. As we already seen, it shows red color, so it's a strong acid. So we can write, if for a strong acid the pH should be in a range of 1 to 3, but we can write 1 or you can write 2 also or 3 also. Okay, identify the gas given off in test 2. Okay, let's see the test for the gas here, which is given on the last page here. We had already seen that the gas produced gives a pop side with the lighted scene. So what's the gas produced? Hydrogen gas. Okay, so we're going to write that here, that the gas given off was hydrogen gas. You can write H2 also because they didn't mention the name, so you can write the formula also, that is hydrogen gas H2. Identify the 3 ions in solution J. Now let's go ahead with the test. Here white precipitates with the chloride, bromide, iodide ions, lilac color flame, and we have already seen that it's an acid. So if it's an acid, hydrogen ion should be present, so H plus is for sure present. Now yes, out of this chloride, bromide, iodide with silver nitrate test, we got the white precipitate, so chloride is present. So we have already got 1 cation, 1 anion, and now yes, lilac color flame. Lilac color flame means potassium ion, so K plus ion is present, and in all acids hydrogen ion is already present. So what are the 3 ions present in our solution J? That is hydrogen ion, chloride ion and potassium ion. These are the 3 ions present in solution J. That's what we have already identified with the above test given. Fine. So this is the end of question 3. Let's go ahead with question 4. It says you are asked to investigate the effect of temperature on the rate of decomposition of aqueous hydrogen peroxide. So okay, we're going to decompose hydrogen peroxide, and we're going to see the effect of temperature on the rate of this reaction. And hydrogen peroxide decomposes to make oxygen gas. So here is the equation given in the word. Hydrogen peroxide decomposes to give water and oxygen. The reaction is very slow unless a catalyst is added to hydrogen peroxide. Manganese 4 oxide is a catalyst for this reaction. Plan an investigation to find out how the temperature of the aqueous hydrogen peroxide affects the rate of catalyzed reaction. So here we need to mention the temperature and know the presence of catalyst, how temperature affects the rate. Your answer should include an explanation of how your results will tell you how the rate of reaction has changed, and you are provided the aqueous hydrogen peroxide, manganese oxide, common laboratory apparatus. Now the most common method of measuring the rate is how the volume of gas produced changes along the reaction. That is, if oxygen gas is produced, we can measure the volume of gas produced for a particular given time. So let's understand the procedure. What are we going to do? We have some hydrogen peroxide, we have a catalyst, and we are supposed to measure the volume of oxygen gas produced per unit time, or the time taken to produce some particular volume of oxygen. I would say that we can measure, say suppose a 10 dm cube or say 5 dm cube of oxygen produced, and how much of time is taken to produce this volume. Measurement of time is very important when we are measuring the rate of reaction. So obviously we are going to measure the time taken. Time taken for what? Let's see, say 5 dm cube of oxygen gas produced. Let's do it that way. You can also say how much time does the reaction takes place to get completed. That also you can do, it depends on you, but here I prefer that how much of time is taken to produce 5 dm cube of oxygen gas. Okay, and we are finding the rate with respect to temperature. So for every reaction we need to change the temperature. So what are we going to do is, let's plan out how are we going to do. So first, what are the things we should keep same? That are we going to make a list here on one side. Actually you can use the rough page also here. Say what are we going to do, keep same. So you're going to keep the volume of hydrogen peroxide same. The catalyst manganese oxide is a solid, so you should keep the mass of manganese 4 oxide, that is MnO2, same. What are you going to change? You're going to change the temperature. And what are you going to measure? You're going to measure the time taken to produce 5 dm cube of oxygen gas. So for all this, what do we need? We need some apparatus in which hydrogen peroxide can be taken, say for example conical flask. We also should mention that the mass of manganese oxide should be kept same. How are we going to measure the time? With the help of stopwatch. How are we going to measure the volume of oxygen? Maybe graduated gas syringe. So we should mention the names, volume of all this in our experiment. So what we can do, let me rub out this line, and then now let's plan out. What are we going to do is take a known volume of hydrogen peroxide in a conical flask. Arrange or set up a sealed glass tube glass tube with conical flask and graduated gas syringe to measure the volume of oxygen gas produced. Okay, this is what we have already done. Now what are we going to do next is that add a known mass of catalyst manganese 4 oxide. You can write it in the whole word, but as I'm going to make it short, doesn't take long in the video, I'm going to write the formula. Known mass of manganese oxide in the conical flask, and seal the flask immediately, and measure the time taken for 5 dm cube of oxygen gas to be produced. The temperature of the solution should be measured at the start of the reaction, start of reaction. Okay, next we can say repeat the experiment at different temperatures with same volume and concentration. Also I'm specifying with the same volume and concentrations of hydrogen peroxide and same mass of manganese 4 oxide added. Measure the time taken to produce 5 dm cube of oxygen gas every time. This is how we are going to mention that we are going to repeat the same experiment every time, but with different temperatures. So everything else should remain same. What everything else should remain same? The volume and concentration of hydrogen peroxide, the mass of manganese oxide taken. You're going to measure the time taken to produce 5 dm cube of oxygen gas every time. Now we need to write the conclusion also at the end. So what conclusion can we draw? We can write that the temperature at which the time taken is least, that is the less time taken is least, is the reaction fastest or have the highest rate, is the reaction fastest or have the highest rate. That is how we are going to conclude that the reaction in which it takes the least time to produce 5 dm cube of oxygen gas, that temperature is giving the highest rate to the reaction. Obviously higher temperature will give the higher rate, so it is going to take less time to produce 5 dm cube of oxygen gas produced. And here ends the last question of this question paper. I hope this is very clear that we plan. I also have a video which specifically teaches how to plan an experiment. I've added a link at the end of this video. You can always watch that and find out that how should we plan specifically this question. So here we end.